two columns of numbers on one sheet of paper, printed in 1988, and nothing in the right column beats anything in the left. 10 megahertz against 8.33, 40 megabytes per second at full width against 33. Bus mastering on both, software configuration on both, and only one removed every jumper from the machine. The left column is IBM's Micro Channel. 9 computer manufacturers read that sheet, agreed with every line of it, and built the right one instead. Compaq had working microchannel prototypes on a bench in Houston and never shipped a single unit. The usual explanation is backward compatibility. Microchannel would not accept an old card, the alternative would, and the industry chose the card drawer over the specification. That explanation is true, and it is aimed at the wrong target. This is the story of the number missing from that spec sheet, and how the best bus of its generation lost to a worse one, built out of parts its own inventor had given away 4 years earlier. You remember the drawer. Half-length cards in gray anti-static bags, a modem, a sound card, a disk controller with a row of jumper blocks along the top edge, and a folded sheet of paper showing which pins to bridge for interrupt 5. That bus was designed inside IBM. Mark Dean and Dennis Moeller filed the patent in 1984 for what the company called the I/O channel. Then IBM printed the whole thing. The Personal Computer Technical Reference Manual laid out the logic and the software in enough detail that a technician could open the case and debug the machine like a television set. IBM published it to attract card makers. Within 4 years, the company had lost control of the platform it invented, and Dean said later that the entire clone ecosystem was an accident of that manual. In April 1987, IBM tried to take it back. The Personal System 2 range arrived, carrying a new bus designed by IBM engineer Chet Heath, and 3 of the 4 launch machines used it. The 4th, the Model 30, kept the old slots, and that detail matters later. The bus had shipped before any of them. In 1986, IBM put it inside the 7552 gearbox, a rack-mountable, ruggedized industrial computer built for factory floors. People who examined one noticed its bus carried more lines than an AT bus could account for, and the extra lines turned out to be a 16-bit micro channel. Nobody at IBM said anything about it because the PS2 had not been announced yet. When it was, the new machines looked different on a desk. Gray-white plastic instead of office beige, a keyboard connector the size of a shirt button, and inside, a row of short, dense slots that would not accept a single card from your drawer. The engineering behind those slots was not marketing. On the old bus, moving a block of data between 2 devices meant routing it through the processor or through a DMA controller, which pushed every byte across the channel 4 separate times. On Micro Channel, a card could seize the bus and hand data straight to another card, with no processor involvement at all. Writing in Australian Personal Computer in May 1988, Pat Moran worked the arithmetic out. A card acting as its own master needed roughly 25% of the channel traffic a DMA controller needed, and it cost the processor almost nothing. Underneath that sat an arbitration scheme with 15 priority levels, with memory refresh holding the top slot and the main processor deliberately holding the bottom one. Interrupts became level sensitive, so 2 cards could share a line without either losing a request, and IBM built circuitry into the system board to stop anyone reprogramming the controller back to the old edge-triggered behavior. A card in burst mode could hold the channel for around 12 milliseconds, long enough to service a tape drive without dropping a byte. every burst-capable card also had to implement a fairness rule, which made it stand down afterwards and let every other requesting device take a turn first. None of that is what the industry was reading. For a full year after the announcement, IBM would not say whether anyone else could use it at all. Card makers asked and system builders asked. As late as January 1988, IBM was still talking about the copyrights, the patent applications, and the proprietary design inside the Micro Channel, and stating no intention of licensing any of it. No price and no date on which a price might exist. Consider what that silence does to a factory. A manufacturer planning a 1989 product line had to commit tooling and engineering budget in 1988 against a bus whose license did not exist and might never exist. Every month IBM stayed quiet was a month its competitors could not plan around it. When terms did emerge during 1988, the shape of the deal mattered more than any rate in it. The specification on its own cost relatively little. What IBM wanted was a royalty on every machine shipped, running for as long as that machine stayed on sale, so a competitor's Micro Channel line would pay IBM on every unit for its entire commercial life. The licenses were expensive and hard to get, and IBM decided case by case who received one. Tandy took the license and built the 5000 MC, the first Micro Channel computer from anyone other than IBM. Asked about it, company head John Roach said he was surprised anybody at all would want it, and that Tandy sold the machine because some demand existed. That is the warmest endorsement Micro Channel ever received from outside IBM. The cards themselves cost nearly double what comparable cards for the old bus cost. And the software configuration that was supposed to be the whole selling point lived on a floppy disk called the reference disk, which had to stay married to one specific machine for the rest of that machine's working life. In an office with 4 PS2s, that was an irritation. In a bank with 900, a lost disk meant a computer whose cards could never be reconfigured again. The automatic configuration did not always work either. When it failed, the machine refused to boot, and fixing that by hand was harder than configuring an old card had ever been. The documentation assumed the automation would work, so it left out the addresses and interrupt settings a person would need. An old card shipped with a folded diagram showing every jumper on the board. A Micro Channel adapter shipped without one, on the assumption that nobody would ever need it. None of that killed it. By the end of 1988, IBM counted 600 PS2 products from itself and others, arriving at 40 new ones a month, covering storage, networking, terminal emulation, and graphics. The ecosystem IBM needed had actually arrived. So here is the explanation everybody gives, and here is where it breaks. The story says Micro Channel died because it broke compatibility. It refused every card already in circulation. The industry answered with a bus that accepted them, and the industry won. That account is accurate as far as it goes, and it names the wrong casualty. The bus the industry answered with was called EISA. EIS was fully backward compatible, and EISA died too. It barely sold in desktops and survived less than a decade. Its speed was capped at 8.33 megahertz by the very compatibility that was supposed to save it, and its own designers knew that on the day they announced it. Compatibility explains why the old slots outlived everybody. It cannot explain why the new one lost, because both new ones lost. The two buses were separated by a royalty rate, not by anything printed on that spec sheet. On September 9, 1988, Bill Lowe, who ran IBM's personal computer business, telephoned Rod Canyon at Compaq. The two men had a working relationship, and Canyon took the call. Lowe made an offer. IBM would give Compaq access to Micro Channel that no other manufacturer would receive. In exchange, Canyon would cancel the press conference scheduled for the following week. Read that offer for what it was. With 4 days left, IBM was using its own specification as something to trade, and what it wanted in exchange was a market split between two companies rather than shared with 9. Canyon declined. Lowe told him he thought Canyon was making a big mistake and ended the call. 4 days later, Canyon stood on a stage in New York with 8 other manufacturers behind him. AST Research, Seiko Epson, Hewlett-Packard, NEC, Olivetti, Tandy, Wise, Zenith Data Systems. The trade press called them the Gang of 9. Their announcement was a 32-bit bus called EISA, and the load-bearing sentence in it had nothing to do with megahertz. Compaq had developed the bus at its own expense and was licensing it to the other 8 companies for nothing. Intel and Microsoft both sent people to stand on that stage, which told every card manufacturer in the room where the chipsets and the operating system would land. The commercial position underneath makes the call legible. Compaq had shipped the first 386 personal computer in 1986, beating IBM to Intel's own processor. Between them, the 9 companies on that stage sold more machines than IBM did. Lowe had spent that morning asking a company beating him in the segment that mattered to pay IBM a royalty on every unit it sold. That same day, in the same city, IBM held its own event and introduced the PS2 Model 30 286. It used the AT bus. 17 months after telling its customers the old slots were obsolete, IBM was selling them again in Manhattan on the morning its rivals announced the replacement. IBM gave up the position within 3 months. In December 1988, IBM Entry Systems Vice President Robert Carberry said anyone who wanted a license could come forward, and IBM would give them one. The terms had been the obstacle for 18 months and were dropped the moment the obstacle stopped working. The market had already answered. The Dallas research firm Storeboard put Micro Channel machines at 20.9% of desktop sales by the third quarter of 1988, while the older standard IBM had declared obsolete still held 61.4%. The bus IBM abandoned was outselling the bus it bet the company on by roughly 3-1. Micro Channel never recovered from that week in September. Compaq shelved its prototypes and let the license lapse without shipping a machine. IBM kept the bus alive inside the RS6000 and the AS400, where the customer had no alternative and no opinion about royalties, and where the channel eventually reached 80 megabytes per second. Only NCR backed it comprehensively in personal computers, building its own microchannel chipsets. Then the argument stopped mattering. Intel shipped PCI in 1992, and within about 3 years, it had erased microchannel, EISA, and the VESA local bus together, carrying level-sensitive shared interrupts and software configuration inside it. IBM stopped building microchannel personal computers in 1995. In June 1996, it shipped a PC server using EISA, which meant IBM had bought a license for the standard Compaq, gave away free. The people scattered faster than the hardware. Lowe left IBM for Xerox in December 1988, 3 months after the phone call. Canyon was removed as chief executive of Compaq on October 25, 1991, after a $71 million quarterly loss, and replaced by Eckhard Pfeiffer. The Micro Channel Developers Association, formed to defend the bus, went on holding meetings and cataloging adapters For years after IBM stopped making the machines, the cards are still out there. A 32-bit Micro Channel adapter turns up in a box at a swap meet perhaps once a year, gold fingers still bright, the arbitration level still program selectable, waiting for a reference disk that was thrown out with the machine. The engineering was never the part that failed. The price was. If this brought back something from your own working life, subscribe, and the next one will find you.